I'd like to show you a simple example to demonstrate microburst, which is a fundamental measurement Corvil has that allows us to understand bursts in traffic within the infrastructure and relate them to performance issues that you may be experiencing. Now, in this example, we see a topology view with an exchange on the left-hand side in London, and over on the right-hand side, we see a data center in Frankfurt that's receiving traffic from London. We can also see some alerts have been raised in Frankfurt, and we can also see here that Corvil has highlighted the link from London to Frankfurt in red, whereas the opposite direction is still green. So something's going wrong here. There is a problem. So let's take a look and see if we can figure out what. Over on the top right here, we're looking at the average bit rate of traffic as it's leaving London. And you can see the bursts here are going up to approximately half the link capacity of 100 meg. So the spikes there are about 51 meg. So normally you would see that and think everything's fine. There can't possibly be a bandwidth issue. But what's actually happening is that traffic leaving London is extremely bursty. The bursts of traffic are generated by machines, and they literally only last for a few milliseconds or sometimes only microseconds. And you can have many thousands of them generated within a second. So imagine this, you have a high burst of traffic that lasts for a few milliseconds, but then you average that out over a second here. You really lose that granularity and the visibility of what's really going on. So let's take a look at the microburst graph as well. I'm just going to introduce that here alongside the average, and we now start seeing a very different picture. Corvil at this end here is analysing the traffic as it's heading towards this 100 meg link. So we see bursts of traffic coming off the high-speed LAN in London, and essentially what's happening, these bursts are exceeding link capacity. They're going up 141 meg, so they're much higher than the actual link itself. And what will happen is when these bursts hit the router here, they will get queued up, which causes some queuing latency and potentially loss as well if that queue were to overflow. Now, the thing is, when traffic's generated on a high-speed LAN, it will actually fill that queue much quicker than the queues being emptied by that service provider link. So this is a real problem that can occur. Now, we also have a Corvil appliance at the Frankfurt end, so we're actually able to measure the latency of packets across this link as well, and we're also able to detect any packet loss that may be occurring. So let me just introduce those graphs as well. And now we can see the effect of those blue microbursts in terms of the overall end-to-end latency and packet loss. And you can see there's a correlation here between when we're seeing these latency spikes and when these microbursts are actually occurring. And the effect it's having is pretty much doubling the latency across this link. So the yellow bar there represents the propagation latency between London and Frankfurt, which is around about 4 milliseconds. And you can now see that the bursts in latency are pretty much doubling it to around 8 milliseconds. You also see they don't go much beyond that, and that's because the queue there at that point has now filled up, and any more packets that arrive within that time period are getting dropped. So these microbursts not only are causing latency, they're also causing packet loss as well. And the interesting thing here is that all these effects would be completely invisible to a traditional tool that's just taking a snapshot every second.